This video explains how the three types of chemical bonding work. First, ionic bonding, between metal and non-metal atoms, for example, sodium and chlorine. All metal atoms generally have between 1 and 3 electrons in their outer shell. For example, sodium has 1 in its outer shell, shown as a cross. Non-metal atoms generally have between 4 and 8 electrons in their outer shell. Chlorine, for example, has 7, shown as dots. But all atoms want a full outer shell, so the metal and non-metal atoms do a deal. The metal sodium atom gives its electron away, and the non-metal chlorine atom receives it. Now, they both have full outer shells. But where does the ionic bond come from? Both atoms were neutral, but after trading the electron, the sodium is now a positive ion, and the chlorine is now a negative ion. The oppositely charged ions attract, causing the ionic bond. Many ions attract to form a giant lattice structure. Ionic compounds have interesting properties. Because ionic bonds are strong and act in all directions in the lattice, it takes a lot of energy to break the ionic bonds, giving ionic compounds high melting points. Second, covalent bonding, between non-metal atoms. Let's look at water. Again, all atoms want a full outer shell. Oxygen has 6 outer shell electrons, but needs 8. Hydrogen has 1 electron in its outer shell, but needs 2. But rather than swap electrons like ionic bonding, covalent compounds share electrons. The oxygen atom shares 1 pair of electrons with each hydrogen atom. Each hydrogen now has 2 electrons, and the oxygen has 8. All of them are happy. So where does the bond come from? The shared pairs of electrons are negative, and the nuclei of all atoms are positive. The attraction between them is the covalent bond, and like ionic bonds, they are very strong. Water is one of 3 kinds of covalent compound, called a simple covalent compound. Although covalent bonds are strong, the forces between the small molecules are weak, so it takes little energy to break these weak intermolecular forces, meaning that water and other simple covalent compounds have very low boiling points. However, giant covalent compounds like diamond have very high melting points due to the covalent bonds. And finally, we have metallic bonding between metal atoms such as iron. Iron has 2 electrons on its outer shell, but metal atoms work as a group and share their electrons between them. The electrons form a sea of delocalized electrons, which are free to roam throughout the giant lattice. Where does the bonding come from? Well, the positive nuclei are all held together by the sea of delocalized electrons, like a strong glue. The bonding is very strong, meaning that metal generally has very high melting points. So these are the 3 types of bonding. For a closer look at covalent compounds with some examples, see the following video, and don't forget to like and subscribe.